welcome you all to week 7 code walkthrough session. In this week, we will learn some varied concepts. So like in the previous weeks, we have seen most of the weeks were basically about a particular concept and we expanded upon that. But in this week, we will see a little bit of different types of concepts working together. So we will start with exceptions and error and followed by packages. And then we will see some debugging tools, not debugging tools so to say, but basically some tools or some techniques which are more helpful for us while we are debugging let's say our program or let's say some software that we have created, right? So which are more helpful for us in that situation. So we'll see some of that which we basically call assertions, and then we will see some logging, right? Like most of the programming languages provide a facility to log their log the events which are happening in a program which is running, right? So we'll see logging, how Java provides this logging feature. We will not go into great depth, but we will see basically what logging is. Fine. So before going into the coding part of exceptions, I will just briefly reiterate some basic fundamental concepts. So as we know, Professor Madhavan has taught us that in Java how we do exception is, I'm assuming you guys have all learned Python, and that's why you must have the basic idea of what exceptions are. So in Java how exceptions are dealt with is we have a throwable, and from that throwable the hierarchy goes to there are two types of throwable objects. The first is exception, right? Exception class. This exception is a class, and error. You see, errors are basically caused or are generated due to some system related insufficiency or system related some task which is very internal, and most of the time it is better to leave it to the operating system to, or let's say the Java runtime environment to handle these kind of things. So we will not deal with error, and basically no one deals with errors in that sense mostly. So errors are kept to the OS and the JRE to be handled, are kept for the JRE and the OS to handle that. But what we will deal mostly will be exception. Now let's just, for briefly giving you an example, errors are like Stack Overflow error might happen. Now when we run a process, basically it will have a call stack, internal system stack. Now that system stack, due to multiple usage of resources or sometimes due to different program inaccuracies like memory leak and stuff like that, what might happen in some situation, this internal reserved memory for a particular program which is running as a process in the system might get filled up, and due to that it might also happen if you do a lot of recursive call, right? And that would be a lot of recursive calls. So if you do something like that, then the buffer may overflow, right? So the stack which is inside may get overflowed. So in such situations, since the system is not sufficient to run the program in such a situation, therefore we might get this stack overflow error, or buffer overflow, whatever we call. So those kind of situation might happen. But yeah, so since these are very internal to the system, we will not go into that, and that will be mostly handled by operating system or the JRE. But coming to exceptions, what are exceptions? As I said, you guys have also seen this in Python. Exceptions are mostly runtime errors, which errors mean, not when I'm saying error, don't get confused with this error. Normally we say that runtime some problem happened, we call that as error, right? So in that sense, I'm saying this error is completely different. So some runtime error might happen, and that is what we call exception. But exception is again classified into two parts, and the first is what we call checked exceptions, and the another one is unchecked exception. Now these are not classes. Exception is a class, okay? So exception is a class name. But unchecked and checked are not classes name, they are basically categories. Now within checked exception we will have multiple classes, within unchecked exception we will have multiple classes. Now what is the idea behind these two classes? The basic idea is unchecked exceptions are those exceptions which are not checked by the Java compiler, and that's why we call it unchecked. Whereas checked exceptions are those exceptions which will be checked by the Java compiler. Now what do we mean by this thing, that checked by the compiler? So basically what are exceptions? If you see the meaning of exceptions, you will understand that exception is basically a runtime problem which has occurred, and now you have written the program in such a manner so that by handling, right, you are handling the exception, that if at runtime if something mishap happens, okay, so that mishap can be, that mishap can cause your program to crash. Now you have done exception handling as a part of your code, and that's why that mishap can be handled and your program can be either continued with changed state, right? So whatever changes you need to make, you detect an exception which has occurred at runtime, you make some changes in the program which is necessary, and you understand the reason that this is the reason why exception has occurred, so I need to make these changes in the code at runtime, and then you restart the code, right? So that might happen as a part of the code itself, right? You can either do that, or you can simply catch the exception and say that okay, there is some error, and there is some exception that has occurred, and that's why I want to gracefully terminate the program. So either of these two things can be done, and we will see in code both of these examples. Either you can terminate the program gracefully, or you can also, let's say, change some things in the code which might have led to that exception, and then again you can restart the code from the starting. So basically you are handling a runtime mishap or runtime error which has occurred so that the program does not crash, and depending upon the programmer's choice, it might again change its state and restart, or it might terminate in a graceful manner. So this is what exceptions are mainly created for. But then what is the idea behind these two categories, checked and unchecked? So see, unchecked exceptions are such exceptions which are mainly caused by the reason that they are caused are basically programmer's mistake. Now mistake means what? The programmer has done some logical error in the logical error in the code, and that's why what happens is at the runtime when the code is running, then some error is occurring. Now logical errors are not detected by the compiler, right? Unlike compiler error or syntax error, they cannot be detected by the compiler. They will only cause problem when at runtime the code is running, and due to some, your logical error, there is some mishap in the working of the code. So in such situation, because of your mistake, your means the programmer's mistake, is if some exception has occurred, those exceptions are primarily are categorized as unchecked exception. Okay. The reason we call unchecked exception is that the Java compiler doesn't check for this exception. Now, what do we mean by that? We will come to that, right? But the main primary reason this unchecked exception category is created is because to separate exceptions into two parts, in which the unchecked part primarily deals with those kind of exceptions which might occur because of the logical error of the programmer. And now coming to the point, why are they unchecked? Why they are not checked? The reason is these exceptions should not be caught, and these exceptions should not be directly handled or ignored. Okay, if such an exception happen, so as I said, primarily exception is created as a concept as a part of any programming language, because if at runtime something happens, you have a workaround for that, right? So, but in unchecked exceptions, the idea behind it is you should not have a workaround. If an unchecked exception is happening in your code, you should not catch it, you should not handle it, you should not like in Python you guys have written this catch. If you try something and if the problem occurs, if an exception occurs, you basically handle it in the exception handler part, the next part, right, after finishing try. So likewise in Java we use the catch keyword to catch the exception and handle it, but ideally speaking unchecked exception should not be handled. Unchecked exception should be it should be allowed to be generated and it should not be worked around with, right? And we should basically, if an exception of unchecked category is happening, we should go to the code and fix the logic where we have done error, right? So because so that is the point. But checked exception are what kind of exception? Primarily checked exception are those exceptions which are very native to a particular application that I am building, and I want some facilities to be there. So as we will see in our code, we might ask the user to input some values, and maybe the user has entered some value which is not accepted by the logic of our program. So maybe we are maybe our program is returning the sign inverse of whatever the user enters, right? Now we know the sign inverse function will not take any value which is greater than 1, because the sign function's domain is always from 0 to 1, right? So that's why my sign inverse cannot be greater than 1 in the natural numbers domain. It will never be greater than 1. But I ask the user to give a value and we will return the sign inverse of that value. And let's say the user entered value 1.8 or 2 or 5 or whatever, something greater than 1. Now that is something which is not acceptable by your code. So what we can do is we can define a customized exception, right? So now see, we can also define customized exception. So Java has both two kinds of exception. First is either we can define our own exception, and also we can have some predefined exception. So we will see all those classes just now. But so we can define a customized exception, and there are some process for that. We need to extend the exception class, and we will define a new exception. And in that exception, if such a situation occurs at runtime, if the user enters a greater than 1 value, then we might throw that exception. And that exception will be handled by a catch handler, and it will, let's say, print to the user that you have entered some illegal value. The value should be within 1, right? Something 0 to 1. So something like this might be printed to the console, and maybe again we might ask the user to re-enter the value, and then the program might again continue from the start with the new re-entered value between 0 to 1 by the user. So you see, here the code is not crashing or anything, but we are restarting the code by throwing an exception, customized exception, and then we are informing the user about the problem, and then we are kind of restarting the code from the beginning, because the previous iteration values entered by the user was illegal. So something like this can be made, and those kind of exception which we mostly make customized, the user defined exception, they are called mostly checked exception, right? The Java compiler will check for this exception, and these are not any logical error or something. Rather, these are functionalities or security measures for your program to have a more graceful and let's say meaningful termination or meaningful continuation, depending upon the situation, in case of any runtime error happening. So since these are features, or these are let's say a functionality that we are exploiting, that's why we inform the compiler by what is the process of informing the compiler about this exception. We will see that, but we somehow inform the compiler that this is exception type that I have created, which I need to do something. So we need to tell the compiler this thing. If we do not tell the compiler will think this is an error, right? So we tell the compiler. So therefore, these kind of exception, the customized exception, are when we are telling the compiler, that means the compiler is basically checking for that. So therefore, these kind of exceptions are called checked exception, right? And if you do not tell the compiler, it will create an error. Compiler will show an compilation error if you do not tell the compiler about this checked exception. But if you do not tell the compiler about any unchecked exception, then the compiler will not show any compilation error. It will just send the program to the runtime, and when the program is running, it will get into trouble. It will basically, the exception will be caused. So the reason for that is, again, the philosophy behind this compiler not stopping unchecked exception but stopping checked exception is unchecked exception should not be handled or should not be forwarded to the runtime or should not be handled by catch handlers at runtime. Unchecked exception, if occurred, let it occur and then simply correct the code where we have caused some mess because of which this unchecked exception are getting lost. So this is the philosophy behind the programming part of this code, and primarily we will see that unchecked exception will have runtime exceptions. This is a class name. Okay, now unchecked exception is not a class name, as I told, it is a category, but runtime exception is a particular class name which is a kind of unchecked exception. Now within runtime exception we also have arithmetic exception, right, and some other example like array index, out of bound exception, dot dot dot. There are multiple such kinds. Okay, and checked exception, as we said, that mostly it is something that we define. There are a few unchecked other category exceptions also, but mostly these are customized exception, user defined exception. Okay, so we'll come to the coding part now. By the way, so in Java, what we do is basically we put the exception in the try block, I mean the lines of code which might generate an exception, followed by a catch block. There can be multiple catch blocks, and here we will basically catch the exception. We will see the format. So we will catch the exception, and there can be multiple catch blocks as well. Okay, as we have seen. And as in the lecture sir has taught us that the order in which if we have multiple exception object in each of this catch block, then the catch block which is nearest to the try block should have the most the lowest subtype of the object, or let's say the narrowest of the object. Not narrowest, what I mean is, so basically we have, let's say, multiple exception class objects, and then the one which is the ultimate child, right, which is the child in the lowest hierarchy, like all others are basically its parents or one level, a different level of parent. So that child exception object should be put nearest to the try, followed by the next parent, followed by next parent, if you are using multiple exception, if they are in an inheritance hierarchy. And at the last we must have the exception class. So maybe at the last catch we can have the exception, exception object. Why? Because exception is the parent class of all exceptions, so it will accept all kind of exception. Now why this should be done in this manner? Why the subclass should be at the top and followed by the corresponding hierarchical superclasses, and the exception, which is ultimate superclass, should be at the end? The reason is we will try to handle the exception in the catch block, right? So basically, depending upon what are we catching in this block, we will write different kind of code in each of this catch block. Now if I have a very specific kind of object at the top, then so that will be caught by only, so if an error, if an exception occurs, then only this catch block will catch it. But if I write this top exception, this exception at the top, then any kind of exception occur, then this catch block will catch it, and then we will not know that what is that particular type within the exception class which has occurred, and that's why we will not have these different kinds of handlers to handle different kinds of exception, right? So because this, if I write exception at the top, that will accept all kind of exception. I mean, irrespective of what kind is generated, it will accept, and then I will not know which particular subtype of exception has been generated by the code, and we will not be able to accordingly customize different handlers, or let's say different lines of code for different kind of exception. Got the point? So that's why we will do that. Another thing is catch block is not compulsory to write with a try block, but in that case you must have a finally block, right? So again, we can have finally also with catch, that is not a problem. So try, catch, finally can all be there together. Try can be there with a finally, try can also be there with a catch, but try cannot be there alone. So these are some points. Okay. And any data member, if you define a data member within the try block, right, then you cannot access it in the catch or finally block, because since the reason for that is try blocks are generally created as a containers where some exception might happen, and if it happens, then we will directly switch the context and move to the one of the catch block. So since the context is getting switched, therefore it is very difficult to access the variable defined within the try block. So if you want to do some variable manipulation or something with what, so basically if you want to operate on some data member or some variable or something, some resource, then you should define it outside the try block in the, let's say, in the main method or whatever, wherever you are using this try class, just define that particular object or variable or whatever outside the try block. If you define it inside the try block, that will not be accessible within any one of the catch blocks. Okay, fine. Another thing I would briefly discuss, I will not write in program because this is kind of not that important. So let's say I have in try, I have returned 5, and then I write finally, and inside finally I say return 10, right? And let's say this basically is within a function, right? Within a function fun, this whole thing. Okay, and in the main method I'm calling this function, and I'm printing system.out.println fun. So that will return either 5 or 10, right? So what do you think should be returned by this code? So if you run this program, basically write this function, and then in the main method just simply println fun. If you write that, then the value will be 10. See, at first try block will be executed. It's not that try is not executed. Fun, obviously with the control will shift inside fun method. It will at first go and try to execute the try method. This block, try block. But the thing is, finally is made in such a way inside Java that whenever your program is basically returning, so this fun method is called, right? So main is calling this fun method. Inside main, this fun method is called. Now when this context of this fun method will be switched, and we will return from fun to main, we will come back from fun method to main method. that is the point where finally must be compulsorily be executed. So finally will always be executed irrespective of whether there is an exception generated within try block or whether there is no exception generated within try block. So whatever you do finally will be executed compulsorily. So that's why in this case the return value will be 10, and so once the control comes inside try at first, it will see return 5. Now just before going to return the value to the context, we know whenever the context switch happen, finally will be executed. So we will go and try to execute finally first. Now finally also has a return statement. Now this return statement will be executed, and this return will be waiting to be finally, to the result to be returned. But this return will be executed while doing the context switch to main method again from fun method. So therefore the result will be 10. So be aware of this. Finally will be, I gave this example because what I mean from this example is finally will be executed no matter what you do, no matter try, whether there is an exception in try or not, or whatever, whether there is an exception in catch or not, finally will be executed. So we have discussed all the fundamental parts. Now we will go into the code and quickly see different example. Okay, one more point is that in the Java slides, what you might see that a lot of code will not understandable, and the reason for that is sir has used some examples which are not currently we have not understood. We have not read all the points or all the parts of Java, and that's why that part is not understood, is unknown to us. But the thing is, those are the examples where basically really the essence of exception, or we will so the essence of exception, or how really such in real life code how such exceptions are generated, you will be able to get a flavor of that. But only thing is we don't know all those concepts now, but once we complete the course it will be very much familiar to us. But anyways, what we will do in this walkthrough session is we will go through all those concepts, but we will use some other exceptions which are which we already know or which we will understand in a better way. But before starting this walkthrough, I would just mention one very important point. Till now I have told you that we will not it is not a good program designed to always catch and handle unchecked exception. Unchecked exception should be allowed to happen, and you read where it is happening and go and correct your code. But since we do not know a lot of other exception type as of now, right, as a part of our course curriculum, that's why we will give you the exception example using unchecked exception only, like runtime exception, array index, out of bound exception, arithmetic exception, because they're easy to operate upon. Otherwise I will also have to write code which will mostly be unknown to you, because there will be SQL connection, there will be file stream connection, because those are the places where resource unavailability might occur and real kind of exceptions might happen. So we will discuss the idea with simple exceptions, but from a software engineering point of view, please understand unchecked exception should not be, whatever you do it with checked exception. Unchecked exception is happening, then correct your code. Right, this idea should be clear in your head. But to discuss the concepts of exception, how exceptions work in Java, we will use unchecked exception just for the sake of understanding purpose. So let's keep this thing in mind. Okay, so now let us see this thing. What we will do in this code is basically we have a sides of triangle array at line number 11, right? And this array is basically, as you can see, it is a perfect square numbers. And in this code, what we will try to do is we will ask the user to input a stride length. So stride length is basically, let's say if the user enters stride to be 3, right? So in that case, what will happen is I will do summation of 1 and the third number from 1, so which is 16. Then again I will do summation of 16 and the third number from 60, which is 49. And again do the third summation of 49 and 100, third number, right? So whatever stride length, which is the jump length the user will enter, that I will basically, jump through the sides of triangle array and sum up all those pairs of number. Right. So this is what I'm trying to do, and basically you will understand if I'm summing up two squared numbers which are basically named sides of triangle. So that means I'm basically summing two sides of a triangle and squared summation, which will give me a hypotenuse square value, considering the triangle is right angle triangle. So this will give me a hypotenuse square value. So this kind of Pythagoras theorem's application, not application, displaying Pythagoras theorem. Okay. So so let's see how we can do it. First of all, we have this do while loop, because as I said, this program how it will work is, if there is an exception in this code, we will basically try to handle it, and if it is, if we can handle it, then we can again ask the user to re-enter a correct value, or we will change the state of the code by changing some variables, by changing some conditions, and then again we will restart the code from the start. So I will not let the code to crash because of some exception. This is what is exception handling all about, right? We will not let the code to crash. If we allow it to crash, then it should at least do it gracefully, properly, with some proper printed messages, what happened and stuff like that. So let us get into the code and we will understand it much better. So because we need this thing that we multiple times, we will again restart the code unless and until the user wants to terminate it. Therefore we use this do while loop to have this effect of restarting it again and again unless and until we choose to terminate the code. So we have had this do while loop, and then I am starting my try block. Now what we are doing is, as I said, that we are basically asking the user to enter a stride length, and in line number 19, as you can see, that I'm taking in the value of stride using a scanner class nextInt function call. But then again I have a dummy call to next line method. So those of you who have not done, we have not practiced Java a lot, would not have encountered this, but those who have written code on their own, they will feel this thing. They will might have already experienced it. What happens is, when you are using the scanner class object, to read both integer or any numeric type value along with string type value. So in this code we are both using S object to read integer values and also to read string values from the console. basically character values, but whatever, basically, yeah. So you are reading character type or string type, along with that you are also reading integer type. In such a situation, what really happens is, so this s.nextInt will read the integer, but will be from the console, but after that integer is over, there is an empty line after that, a series of blank spaces, right? So what happens is that next time when you do again nextInt, right, so it will basically try and read that blank space, and then you will get into trouble. Or let's say you read a next line, so that blank space line will be read by Java. I mean, whatever was after that, because the read pointer is waiting just after that integer, and now the blank space is starting. And if you do a next line, then the blank space will be read. So that's why what we do is we put a dummy next line. So what that dummy next line does is it reads that blank space and just wastes it, right? Because we are not storing it into any place. So by doing this, what happens is next time when you write a next line or nextInt, it will actually go to the actual next string that has to be read or next number that has to be read. Okay, so whenever you are using both integer and numeric type and string type reading using scanner class object in a Java program, after using the numeric type read, always use a dummy next line. Fine. So after that, what we are doing is, since we will basically say that we will sum up the I plus stride, ith plus I plus stride amount, I plus stride, whatever that index is, that particular element, we will sum that up. So we will have multiple such pairs, right? And how many pairs we will get? That is basically side of the triangle, size of this array, which stores the side of the triangle, right? So that the size of that array divided by the stride length that we got. So then we will get the number of iterations, right? So that's why we are basically creating a hypotenuse array after that, which will be equal to the number of iterations now. And then we got the iteration variable. Then basically what we are doing is we are summing up the ith and I plus strideth entry and storing it into the hypotenuse squared array. And this is basically a while loop. You can just understand what it is. And then we are finally printing the hypotenuse. And then we are asking the user that whether you want to continue it or not. Right. So the user enters a stride. We from the stride we calculate the size of the hypotenuse array that we need to declare, because so many pairs will be there depending upon the stride, right? So and that is basically the sides of the triangle length dot divided by stride. And after that we are basically calculating the hypotenuse elements, and then we are printing the hypotenuse array. And then finally we are saying the user if you want to continue, if yes, enter y, otherwise no. So this is the code. But now what kind of exception might happen over here? See, the first thing is the user might enter a 0 value. So if the user enters a stride to be 0, the user is free to enter anything. So if he enters 0, what will happen is we will get a divide by 0 exception at line number 20. Now there is no divide by 0 exception, but what we actually call it in Java is arithmetic exception. So there will be an arithmetic exception generated at runtime, which is basically caused due to divide by 0 effect, and because the stride length was 0. Okay, so that might happen. Another thing that might happen over here is, let's say the user enters a stride length of 2. Okay, so if the user enters a stride length of 2, let's go at the top. What will happen? 1 and 9 will be summed up, 9 and 25 will be summed up, 25 49 will be summed up, 49 81 will be summed up, and after that what will happen? 81 is summed up, and after that we do not have a alternate element, I mean the second element. So 81 100 and 100, there is no next element after 100. So how many iterations did we have? 1 and 9 is one iteration, 9 and 25 is second iteration, 25 and 49 is third iteration, 49 81 is fourth iteration, and that's it. We have only 4 iterations possible if the stride length is 2 and 4 pairs of number. But if we calculate the iteration variable, what is the value of the iteration variable? So this length will be 10, right? We have this array length is 10 divided by 2, stride is 2, which is 5. So we saw that there are 5 possible pairings, but the iteration will be, there are 4 possible pairings, but iteration value will be 5. So the hypotenuse array will be of length 5. And if this hypotenuse array is of length 5, so what will happen? I will try to store the 5th iteration, right? So this iteration is also 5. So in the 5th iteration, what will happen? In the 5th iteration, what will happen is the sides of triangle SQI, right? This part. This part of the code will basically be pointing at 81, and this part of the code, the I plus stride value, it will go out of bound, because now 81 plus 2, stride is 2, right? So 81 plus 2 is one element after 100, but there is no such element. So that means basically array index out of bound exception will be caused, because you are going out of the array index, right? So these are the two kinds of exception that might happen over here. And keep in mind, as I said again, both of these are unchecked exception, okay? Runtime exception. So here we are doing the example because of introduction to exception. I mean, we want to have a basic introduction to exception, but ideally speaking, we should not, have handler and all these things for unchecked exception, right? We should solve it. Because as you can see over here, these are coding errors. So the main problem over here is we have not written -1. If I write -1, all this negative array, array index out of bound will never happen. Right? So these are logical errors that causes this kind of exception. But anyways, here we will discuss it using this example for ease of understanding. Okay, so since we have discussed what kind of exception might occur, now we will see how to handle them. So here I am handling the divide by 0 exception, which is basically arithmetic exception. Okay, so handling, while doing the handling in the catch method, right? There are, not catch method, catch block. How we can handle it is, there are multiple methods provided with the exception object. So we can have the get message method, so that will return a message or print a message, which will give some information about the type of exception that has occurred. So this get message will print divide by 0 exception. So this is an arithmetic exception, but arithmetic exception can be caused by multiple situations. So that e.get message will print that okay, this arithmetic exception is caused by divide by 0 problem. Okay, so that is done. There is another method called print stack trace. We will see that in the next handlers, that next catch blocks, that will print the trace stack trace, that at what line the exception has occurred, right? And then what happened, where is that exception being passed to, all those information will be given. So fine. So in this line, what we are doing is we are basically printing a message of what happened, and then we are asking the user that please enter non-zero stride. That you have entered a zero value, that's why this has happened, and please enter a non-zero stride, and if you want to continue, then press Y. So then again we are accepting the choice of the user, and then hopefully in the next iteration the user will give a proper non-zero value. So what happens is, once this catch block is over, after displaying the message to the user, and let's say the user says that he wants to continue, once this catch block is over, the whole thing will go to this while check, right, while this condition, and since the user has entered Y, it will again go to the start of the code and start from here, enter the stride length. So see, there is an exception being generated at runtime, but the code is not crashing. We are basically restarting the code with new condition. The new condition in this case was what? We displayed to the user that please enter non-zero values. So next time the user will enter some legal values and the code will work. Okay, so next is runtime exception. This runtime exception, inside it we are checking it is an array index out of bound exception, and you can also would have checked it directly over here, but then we would not have this particular lines of code. But anyway, so what we are doing is we are checking for next runtime exception, and then inside that we are checking for is it because of array index out of bound. So if it is array index out of bound, we know that we also discussed that this might also occur, array index out of bound exception, right? When we enter, let's say, stride length of 2, this might happen, or some other stride length also this might happen, right? So we are printing array indexing issue, and see here we are doing the print stack trace, and we are printing the stack trace, that what happened, and then we are kind of exiting. So you can also exit the code, as I told you that you can do whatever you want to do by in the handler, and then at the end of the day you can exit the code. So that's what we are doing. The system.exit is used to close the code, because we have done really something wrong. That's why the array is going out of bound. So we are closing the code at that point. Okay. And then at the end we have this exception E. As I told you, in any exception catch block should have the last exception E, so that if some exception is generated which we did not kept in mind, which we could not keep in mind, so then that will be accepted by the exception class object in the last catch block. And then again we are printing the stack trace. So this is how it is. This is how basically this code works. We are handling the exception by different catch blocks. Now we will go to another code. That code is very much motivated from this code only. Only thing is, here we are asking the the user to enter a particular stride value. In the next code we will see, we will ask the user to just enter two bounds, I mean maximum and minimum value, and we will pick 10 different strides, right? We will pick 10 different stride values within those max and min bounds, and that stride will be picked up, I mean that values will be picked up at random. It can be anything. Now what will happen in that situation? See, again the same trouble. If the values given by the user, the minimum value that given by the user, the bound given by the user is in the negative number domain, then my random number selection will even generate negative numbers within that range, right? So then my stride will be negative, and then again I will have this different trouble because of size of the array, negative array size index, and all this kind of stuff. All right. So we have to take care of that. But the thing is, the problem in this case is having a dividing by negative number is a problem. Sorry, dividing by 0 is a illegal operation, but dividing by negative number or something like that is not an illegal operation. Only thing is you cannot have an index negative while declaring an array. But other than that, there is no such like here divide by 0. When you divide by 0, automatically there is a divide by 0 exception being raised. But there, no such exception will be raised if you are entering a negative number and dividing by a negative number. So that's why what we do is, in order to have this feature implemented, we define an exception class, a user defined exception. We will see that now. So we have this class negative exception class, and the way to define any new exception, as we already told you, users can define exception in Java, and the way to do that is we extend the exception class. So we have that parent class in this hierarchy exception class, right? So we will extend the exception class, and we will define the constructor of that negative exception new class, right? So what we are doing in the constructor is, let's say that message that I said that we have this get message which prints the message with respect to a particular exception object. So if we want, since now we are creating our own exception, customized exception, we also want messages to be printed to the console if such an exception has occurred, and it should be shown on the console. So that's why we are accepting this message, and then we are passing this message to the super constructor of the exception, negative exception class, which is basically constructor of the exception class. So that will do the attachment of this message with the object and all other background stuff. And this is basically how the syntax is. So this much will be enough. Have a class, extend exception, and define the constructor. That's it. Now you have a new exception class. So whenever you create a new object of this negative exception, it will be as good as generating a real error in the program, and the program will stop if you not handle it. Right. Oh, by the way, why I'm overriding this toString method? Because I want this negative exception with error value, this to be printed whenever I'm writing system.out.println obj, where obj is negative exception class object. Right. So we are basically overriding toString method so as to allow the println method or print method to print in this format. The object, right? Object of this negative exception class. Okay. So now what we are trying to do in this code is, now what we have defined here after this a linear list extend linked list integer. What is this happening? So in the previous example we have only one stride value, right? Depending upon what the user is entered. But here we have 10. We will have 10 different stride value between the range the user has given, and we will see that in the code. And because if it has 10 different stride value, we need to store it somewhere, right? So where we will store it, we define a linked list. Why we define a linked list and not already use the concrete implementation of linked list? The idea is, since I do not want negative numbers to be inserted by the user, or negative numbers to be generated, not inserted, in this case it is generated. So negative numbers not to be generated or not to be put inside the stride values, what we will do is we will override the add method of the customized linked list. So we have actually thought of customizing a linked list with only the add method overridden. So how it works is, we have this class linear list extend links list, and then what we do is we have this add method of linked list add, right? So we are overriding it. How you are overriding it? If a negative number I, so whenever you if you are defining a linked list for stride, right, then how will you put the stride values within that linked list? By using the add method. So whenever you are writing add method, this internal query will be fired, I mean this thing will be fired, function, and the add method will see if I is less than 0 negative, then you throw a negative exception and give this value. Okay, so this is a feature that we are implementing based upon our requirement. So this is not any real Java's internal exception or something. We are basically creating a feature in order to check whether there is a negative value entered or not, right? So okay, so we have this negative exception that we are throwing, and once this part is over, because our main idea was to implement this negative exception depending upon the value. So all the other tasks that has to be done by the add method, we are leaving it to the superclass add method. So that's why we are writing return super.add. So then superclass will add it and do whatever, right? So add the values into the linked list, and all other background stuff it will be handled, and we have just overridden the add method, this one part which will check before adding it to the data structure, it will check whether that value is negative or not. If not, then it will allow, otherwise it will not allow, right? So that is a custom exception. Now let us go to the main method and see. So as I said, we are initializing the sides of triangle array with 30 members in this case, right? And then we are having this max min summation, I mean max min being entered by the user. After that, we same reason do and while loop is there for multiple times trying. And then we have this try block, right? And then what I'm doing over here is, unlike the previous example, we are not coding the whole thing within this try block itself. We are basically calling a function within the try block and passing the necessary arguments to that function. Okay, so now let's go to that function and see what happens. So public static void random hypotenuse, then you accept one linked list, and then you accept a maximum and minimum, right? So this is how it is. And I will come to some parts I have also not discussed, like what is this throws keyword, what is this throw keyword, right? I will come to that, just give me some time. At first let us discuss the basic structure of the code, then we will go to the specifics. Okay, so this method is called, now inside this method we are accepting those sides of triangle and maximum minimum limit within which the random numbers have to be generated, or the stride length, and here we will generate 10 such numbers, okay, 10 such stride length, and yeah, so that's it, and then we are adding it to the val. So this add method, this is internally checking if there is a negative number or not, right? As we have already overridden this add method over here, right? So sorry, over here, yeah, so this add method is overridden over here, so it will check for this exception. And okay, so how exception objects are created in Java? If a new exception is occur and you want to launch it, then you use the throw keyword. So if this is negative number, I told you that we will basically throw the exception, right? We will try to inform the compiler that there has been a exception. Okay, one thing is that what, so throw is fine, throw is used for throwing the newly generated exception, but what is this throws word? See, this throws word is basically where you are informing the compiler about checked exceptions, right? As I already told you in the initial part of this discussion, that there is a way to tell the compiler that this method will throw an exception, and that is basically internally you see this is anyway throwing an exception. So to let the compiler know that okay, this is throwing an exception, that's why I mean I will handle it later on, you don't get worried now. So that's why this throws keyword is used. If you delete this throws keyword, right, I mean throws the negative exception, if you remove this whole thing, then this compiler will give a compilation error. Why? Because compiler will see that there is a negative exception being thrown and not handled anywhere. But if you write throws in the method definition, that will tell the compiler, okay, so he has written throws in the method definition, means that at this point, at this level, inside the, which class is it? Inside the negative exception class, I am not handling the exception, right? But later on, when this add method is used, right, I will put the add method inside the try catch block. So I will handle it over there. Okay, so this was the reason. So I will handle that, yeah, so I will encapsulate that add method inside the try catch block over there, and there we will catch the exception if generated and handle it over there. But now I do not want to handle it at this point, otherwise I will have to put try catch encapsulation between this code also, right? But that I don't want to do, and that's why I tell the compiler that you also don't get worried, just ignore as of now, and because this is throwing negative exception. Okay, so now this is done. Yeah, so here we are generating the strides. Likewise, everything else is same. I am not discussing this code. It's basically the same thing. Just now there it was only one stride value. Now it is basically an array of numbers. That's it. Fine. So let us see the exception that gets handled. Right. So first arithmetic exception, like zero is still a problem. Then we have runtime exception, array index out of bound because of this negative. Not negative, due to some some stride length like 2 and all. Right. And then finally we have this negative exception. So you see that here I am using the add method, and as I told you that add method is inside the try catch block. Right. Okay, so yeah, negative exception E, what we are trying to do now. First of all, now this is something again new, one new concept. So till now we could have caught this negative exception just like any other exception, and we could have simply printed the stack trace, or let's say we could have informed the user, whatever. But what we will do in a display of another functionality, that is called setting up initialize causes of a particular exception or chaining of exception. So how is it working? So see, when you're working on a big project, big software, then let's say it has a database side, SQL or Postgres or whatever. Then let's say it has a web server, website. Then let's say it has an internal working site. So there will be many such modules which interact with each other to basically implement the program, right? So what happens is, let's say at one of the internally inside one of the modules code, there is some error happening. Some exception is being generated, and that exception is what happens if you do not handle the exception using try catch block. They will be forwarded one by one according to the call stack. So at some point of time, maybe 10-15 layers down, that exception has not been handled, and it has come to a level where it is handled at this point. Now, what happens in such a situation? So I will not understand, because I'm, let's say, 15 levels down in the hierarchy. I don't understand what kind of exception is this. What was the problem because of which this exception was raised? Right? I will not understand that. So in order for us to understand in big programs or problems, when we want to let's say understand what is the main reason for a particular exception which has occurred. I mean, a lot of times the wordings of this exception will not mean anything to us. So that's what I said. If there are 15 different modules or 15 hierarchy within a big project, and you are working in the bottom one, and let's say from the top, second or third, hierarchy. When I say hierarchy, I mean different technology or modules which are being used. So let's say one module which is very core to the system is basically getting into some exception. So that exception will be carry forwarded until and unless it is handled, or it will be given to the Java JRE, right? So it will be carry forwarded. So at some point, maybe 15 levels down, if I see such an exception is being generated, the handler will not know what is the cause of this exception, because a lot of things has happened between them, right? So we don't know what is the cause and what it is all about. So you can mention it over there. I mean, so what we do is we basically declare in such a situation to eradicate this problem. What we do is we can declare a new exception type which will be more meaningful to us, and we can throw it at this level. Okay, and what we will do is we will say the initialize the cause of this new exception that we have created. The generation of this exception has been caused by the real exception which occurred, right? So let's say if in this code, this negative exception has, negative stride length, it was given, and that's why a negative stride value was considered, and that's why this negative exception is given, right? Is thrown away, right? Negative array size exception. Negative exception because of the negative number. But what happens is, because of the negative number, when we are defining the hypotenuse array, there will be a negative value going inside the size parameter. So a negative size array will be declared, and that is illegal. That is something illegal, and that's why corresponding to that there is an exception class which is called array, which is called over here a negative array size exception. So therefore we define this negative array size new exception as the new array size exception, and we basically throw that new exception by setting the cause of this new exception to be the actual negative exception. So this array size became negative. The reason for that is someone entered a negative value. So a negative array size exception is caused by the negative exception, right? So that's why we initialize the cause of new exception to be E and throw this new exception, right? And let's come to the main method. So as you see that now, not the main method, but I mean is basically, let's now go to the main part. Here. So as you have now executed this code, this line of code, now we come back to over here. And let's say we have thrown one negative array size exception. So that since it is happening in this line, right, we have to handle it. So how to handle it? So we have this try catch blocks, right? So we have placed this call inside the try, and if there is some trouble that is happening, like negative array size exception, as we have written over here in the catch block, right, it will be handled. So how it is handled? System.out.println E, which basically will print the details of the negative array size exception, and then it is printing the real cause of negative exception is something, some get cause, right? What is the cause of that causing a negative array size exception? The real cause is so that is being given by the get cause method. Okay, so what just happened now, that I have selected, or I have initiated the this exception. I have initiated the array negative size exception with negative integer, negative exception, right? With our own this negative exception, and the initial cause of array size negative is negative exception, and this negative exception is, now we can get that cause by using the get cause method. So you can see over here e.get cause. So there we use the set cause, now we use get cause, e.get cause. Okay, so again this exception is the same thing, iterations and all this thing. Anyways, so let us now define a little bit about this public static void random hypotenuse square. So here we told that throws negative array size exception, right? Because this is again by the way, if I do not mention this throws, what will happen? Let us see that. Not here. Sorry. So if I do not write this throws, what will happen? Any problem? Did we run into any trouble? See, no problem, right? Nowhere any error is given. So that was a redundant line. Is it so? So then is it also a redundant line where we mentioned this negative exception? Delete it. Then suddenly it is showing error. So what is happening there? It did not show error. So this is the checked and unchecked category. I told you. So this is a checked exception. So checked exception will be checked by the compiler. So you have to inform the compiler that okay, don't get angry now. I will handle it later. So that's I'm not putting it under try catch within the method definition here itself, but I will handle it later. So that's why it throws your negative exception. Okay. But here it is unchecked type exception, right? So here it is not compulsory to mention throws unchecked exception over here. But if it would have been, why? Because negative array size exception is a predefined exception, not something which is customized by us or we have created. It is a predefined exception. Where is that? Yeah. So this negative array size exception is a predefined exception, right? And that it is an untimed exception. So that is basically it is an unchecked exception. So that's why, since it is an unchecked exception, right? So it is not compulsory to be mentioned in the throws keyword. But if it would have been a checked exception, right? So then we have to. So let's say if I wouldn't have done this init cause and would have directly, where is it init cause? Yeah, if we wouldn't have done this init cause and would have directly thrown the negative exception that we have got over here, right? Then we could be in. So then this we have to mention properly that it throws negative exception in such a situation. Anyways, since we had already written it, so let's keep it as like that only. Since as I already told you, we are doing, for the sake of simplicity, we are doing all these example with simple unchecked exception class type. But reality is we should always do these things with real checked exception class type, and this is the reason somehow the lectures uses those specific kind of codes, which are a little bit difficult for us to understand now because we don't know file handling and all those stuff. So throws, let us say I will write runtime exception. I can write anything which is super class, right, of the given exception class, runtime exception. Okay, so I think we have discussed all these things. Yeah, so that is I think it for exceptions. So how we can create exception and what are the basic kinds of exception, and how we are using it, right? Okay, fine. So this exception part is kind of over. In the next discussion, I will do it as two-part session. In the next part, we will see the Java packages, assertion and logging. So I thank you all. We will wait for you in the next session. Thank you.